guys, and welcome to another Solar Squad video update. My name is Abisai, this is Kameron, this is Zach, and this is Mandy. Last week, we left you guys on our official prototype design, in which we also stated that several changes were going to be made because of the way we have been constructing our wiring and our components around the design. Now, in this video, we'll be talking about some in-depth research that we have been conducting this past week. And as we have found out, there's a lot more to our project than what we first thought. And of course, it's brought its challenges, but we're excited to show you and share with you what we've learned.
Okay, so during this past week, we've settled on our final measurements for our base, and we're going to be working in the wood shop, or the mechanical engineering shop, and cutting our materials and finalizing that design. And I personally have been looking up the solar cells and how to connect them in a series. So that has not changed our design. We're still going to keep it the same way, but I figured out how to connect the wires and make sure that they will transfer the energy properly. And now Zach is going to show you how his diagram of the circuit is going to let the power go through our whole circuit.
Okay, so here is the diagram of our electrical circuit that we designed together as a group. And right here, this is our source of energy, or electricity, and it represents our solar cells. And here's a USB charger and our VEX 393 motor, which represents the load of our circuit. So the electricity will flow this way until it hits this parallel, which means that both loads are side by side. So the current has two ways to choose from. So right here, if you have these right here are called switches. So if this switch is on and this is off, the current will automatically go this way, which will allow us to charge the phone with the USB charger, and it will just keep going as a flow of electricity. But if you have this open and this closed, it'll run the VEX 393 motor, which will make our car move. And if you have them both closed at the same time, which makes the circuit complete, the electric current will choose which path to take, causing our phone to be charging and for the car to move.
So, just as how Mandy and Zach explained exactly the terminology behind our circuits for our prototype, I will now just give a quick overview of what exactly the electrical components will function with our prototype. Now, we will use our solar cells as our power source using the sun or light, and we will start out by first soldering each solar cell put together to create our own small solar panel. Once connecting those together, building that circuit as explained by Mandy and Zach, we will then connect that to a breadboard where we use several jumper cables or jumper wires to connect different parts of the positive and negative components of the breadboard that will then fasten to our motor wires that will then turn and spin an axle to turn the axle with the wheels and eventually push the car.
And now I'm going to show you a bird's eye view of the update we made to our DC motor. Hello guys, this was the original DC motor that we're going to incorporate in our design. Just in case you didn't know, a DC motor is any of a class of rotary electrical machines that converts direct electrical current energy to mechanical energy. It's supposed to assist in turning the wheels of the car we are using. Initially, we were using a 12-volt DC motor produced by Globe Motors, which is this. We discovered that to operate it would require too much energy, which we initially thought the solar cells wouldn't be able to produce alone. It turns out that our solar cells can produce up to 19 volts. We decided to move away from the 12-volt DC motor to a lighter and less energy consuming option. Our second option was the HS422 Deluxe Servo, which we discovered is a small device that incorporates a 2-wire DC motor, a gear train, a potential meter, an integrated circuit, and an output shaft. The voltage range for the device is 4.8 to 6 volts. The downside of the device was that it only allowed for 180 degrees of rotation and that will not allow the car to move a far distance forward. As you can see, it's only 180 degrees of rotation. Finally, we have settled on the VEX 2-wire 393 motor. It operates on 7.2 volts and allows for 360 degrees of rotation. It's about the same size as the HS422 Deluxe and is lighter than our first option.
Thanks for watching this Solar Squad's update number 3 of our solar charging station project. Tune in next week to find out how our design actually looks physically, and like and subscribe. Solar Squad out.